So I'm going to start my thesis presentation with a video that illustrates the main concept of our project.
Do you think you can give me a tip for my master thesis presentation tomorrow about extended reality?
My suggestion for your presentation on extended reality would be to focus on the user experience and how it can be enhanced through the use of VR technology. Highlight the immersive and interactive elements that make extended reality a unique and engaging experience for users.
So this video illustrates the primary concept of my master thesis in software engineering at the Faculty of Science of the University of Lisbon, which is exploring extended reality and AI synergy, crafting an immersive experience for the performance art use case. So the main goal is to create an XR project where people can interact with an AI character, as you just saw by the demo, which is going to narrate multiple of his life events, assisted by multiple VR environments. So, most of you know VR has been associated with gaming, fitness, and entertainment for the last couple of years. But now, big tech companies are envisioning a future where we'll swap our PCs for VR devices and our phones for augmented reality devices. So, we're now starting to face first appearance for productivity apps where people can work with multiple screens and be immersed in virtual environments. We're also now starting to see multiple use cases of social VR and the development of avatars for digital replicas for digital communication. Since it's physically impossible with head-mounted displays to display our faces, and so we are forced to use 3D avatar replicas for digital communication. I also got motivated to research this area because of in 2024, companies like Apple, Sony, and Samsung are investing resources into creating XR head-mounted displays. Another aspect that motivated me was the fact that it's a whole new medium that facilitates a sense of immersion that no other display can create. With a simple 180 recording, as you can see, you can create an experience that makes you think that you're really there. With common digital displays like computers, you can also be immersed in the experience, but VR displays make it way more easier to be immersed. People are still trying to understand how you can create immersive experiences, since it's really different from normal 2D movies, where in 180 or 360 movie recordings you can look at wherever you want, but in movies the director knows that you're going to be looking at the exactly same spot. So with my interest in these technologies and advancements of AI, I wanted to learn with the best. So that's how I met Satore Studio and the TransmiXR EU consortium. The project at the consortium involves 7 European universities, 6 industrial partners, and 8 media collaborators, and they're all motivated by the maturing of these technologies. The project aims to explore the potential of the different tools that are going to be applied in the projects of the 3 different use cases. So the 3 different use cases are cultural heritage, which is the capability of preserving or restoring historical assets in immersive 3D environments. As an example shown here is the Roman Theatre of Lisbon, which was modeled one of my courses in my college. So this is an example of restoring an historical asset, because in the famous Lisbon 1755 earthquake, the building was destroyed, but now in VR we can visit the building in a digital replica. Then we have the second use case, which is the news publishing, where you are capable of choosing what broadcast or of a news channel you would like to see. And the last one is the performance art use case, where creativity has no limitation for creating 3D immersive experiences. So this master thesis will focus on this use case, which is the performance art use case, and will be conducted at Satore Studio, which has been creating VR experiences since 2015. This project will develop the XR project and also documenting the tools and techniques that we use so other people can know how they can create immersive experiences. So before we delve into the technological tools, we'll first define some terms. A single concrete definition for these different technologies remains lacking in the field. Tech companies such as Apple define all of these technologies under the umbrella term of spatial computing. But the academic definition that I find most agreeable is the following. So we have extended reality, which encompasses all of the digital realities. We have augmented reality, which augments reality by adding digital assets that change with interaction with the physical ones. So as you can see by this example, the inputs from the physical keyboard change the digital text box. So then we have mixed reality, which also augments reality by adding digital assets into our environments, but they don't need to interact with the physical ones. And then we have virtual reality, which are fully immersive digital experiences. Then we also have AI, which refers to the simulation of human intelligence by machines. Right now, AI is really good at simulating human conversation, so that's why we're exploring the synergy between AI and XR experiences. So now we are going to define all of the technologies that are going to be applied in this project. We have volumetric video, photogrammetry, motion capture, generative AI, digital human avatars, and 3D asset generation. So for the first one, we have volumetric videos that enable the digitalization and recording of three-dimensional scenarios. This technology is enabled for dynamic shots as seen by the left, and also viewers are able to watch a player's point of view as shown by the right. We don't see a lot of applications of these technologies because they're still new, and you need to do a setup of putting all of the cameras in the stadium, which is and applying the software, which is a hard thing to do. So in our project, we are processing data collected through this volumetric video workshop held in January, where we are creating a 3D capture of these dancers, as you can see right here. So then we have photogrammetry. That is the technique that allows the transformation of physical objects into detailed 3D digital assets by using a series of photographs around the subject in a 360 mirror. Some example applications of these technologies are building a human avatar's texture, as shown in the slide, and also another method of preserving cultural heritage. So, for example, if you wanted to digitize everything in a museum, you could digitize the assets and also the walls and create a 3D replica with your phone. One limitation of digitizing someone is that it's still a complex process that is hard to replicate. Although codec avatars on the left from Matter are more realistic, they were created in the controlled lab environments. But then you have the Apple's avatars that are created on the spot with the Apple Vision Pro. And yeah, although Meta has announced that next year will release their avatars for commercial usage, we're still waiting for a product release. So then we have motion capture tools. Motion capture tools involves the recording of the movements of an object or a person and then applying them to animate a digital character for 3D computer animation. Right now we have Roku and Movie AI that are making these captures with only a mobile phone camera. And they're also exploring the advancements such as multi-person capture with a single smartphone device. Then we have our generative AI that is going to be used to when the users have the opportunity to ask Isaac's questions, and they are not experiencing one of the VR worlds that are used for each scene of the XR experience. So this will be produced by the in-world plugin in an Unreal Engine that generates the text and verbal expressions for our avatar, as you can see. Then we have generative AI for the 2D image generation and also 2D texture generation for our scenes. And we might also use text to 3D generative AI to create 3D models. But as you can see, for now, you cannot create high resolution or concise enough results to be applied in immersive experiences. Then we have digital human avatars that represent humans created by 3D modeling, photogrammetry, and motion capture animation tools. As shown here by the research we have done, we have concluded that it's impossible to replicate someone's face and emotions 100% accurately. So human avatars hold the potential to transform work meetings by eliminating physical constraints. However, ethical questions arise regarding the implications of increasingly relying on digital representations of ourselves in digital human communications. Then the final area is 3D asset generation. This technology enables the creation of 3D assets for immersive environments. For example, you can have a 3D image on the wall, and then it is transformed into a 3D point cloud to create an immersive 3D effect, as you can see by the slide. So our XR experiences focus on Isaac's life, that will be depicted through his narration of his life events and the VR environment, and we're also going to enable the users to talk with him in his home when we're not in VR environments. For example, users can interact with a digital fridge, and Isaac will be triggered and say, please don't finish all of our beers in the fridge. Also in the VR experiences that the users go through, they'll go through the different stages of Isaac's life between 22 and 66. So to create the immersive experience, we'll need to use the multiple tools I referred. We have volumetric video that creates the 3D recordings of people, which, for example, can be when Isaac is telling us a romantic date he had. It can be shown a 3D video of his partner. Then we have second photogrammetry that will be used to create the face texture for the avatar. Then we have motion capture will be used to animate the 3D models of the peoples that Isaac is referring to in his narrative. Then we have generative AI, which will allow us to give life to Isaac and generate digital assets. Then we have Isaac will be our digital human avatar. And then we have a 3D asset generation that will be needed to create the digital assets. For example, Isaac's home furniture. For our forthcoming work and conclusion, currently we are in the research phase as we are investigating these technologies still. But following this, we'll proceed with the development of the XR experience as shown in diagram, where I'll program the framework that connects the multiple VR headsets to the server that will send and will create in real time the digital assets to the different VR devices. For an example, the images that can be generated in the server then will be displayed in the different headsets. Then at the end, we'll do user testing to ensure optimal user experience. And at the end, we'll document our findings and compile them in the Master Thesis final report. And yeah, thanks for your time.